Hello, this is Mr. Best. Welcome to Chapter 4, Trigonometry and Probability, homework questions 58 through 63. Question 58. Out of the 20 contestants in the state math championship, 10 are girls. For this round, each contestant gets asked one question. The first question goes to a randomly chosen contestant. Part A. What is the probability the first contestant is a girl? Well, how many contestants do we have? What is that sample space? There are 20 contestants in the championship. So out of 20 possibilities, there are 10 that are girls. So 10 out of 20, you could reduce that to 1/2 or even write it as a percent. There's a 50% probability that the first contestant is a girl. Part B, if the first contestant is a girl, what is the probability the second contestant is a girl? Well, there were 20 contestants. If the first one was already chosen, now there are only 19 contestants. And there were 10 girls, but one of those were already chosen, so there's only 9 girls now. So 9 girls out of a total of 19 contestants, so that would be your probability. Part C. Is the probability that the second contestant is a girl independent of the first contestant being a girl? Refer to the math notes box at the end of lesson 415. So for it to be independent, then one doesn't have to do with another, and so you can see that from the probabilities from the A to the B, we had 20 contestants, and now we only have 19. So those probabilities would have to be the same if we were choosing a girl, if they were independent of each other. So is the probability that the second contestant is a girl independent of the first? And the answer to that is no, they are not independent of each other. And make sure you go back and look at the math notes box from that lesson to go into a little bit more detail. Question 59. On the graph paper, we're supposed to graph the parabola y equals 2x squared minus 5x minus 3. You can use the Desmos tool. You can use your graphing calculator to help you as well. What are the roots or the x-intercepts of the parabola? So I'm just going to go ahead and graph this on the graphing calculator, look at the table, and get some points to accurately graph the parabola. So when I went ahead and plotted the points that came from the table on the graphing calculator, and it appears that the roots of the x-intercepts of the parabola looks like -1/2 comma 0, and then also 3, 0. And we can verify that on the calculator as well using the trace key and typing in -0.5, and you do get a y value of 0. So it does verify that it is the x-intercept. But also on part B, it's going to actually have us solve algebraically, so we'll also be able to check to see whether it matches up. So on part B, make sure you read the math notes box in this lesson. Then solve the equation 2x squared minus 5x minus 3 equals 0. So they took the y value and replaced it with a 0. So we're solving for the x values when y are 0, which represents the x-intercept. So we're going to figure that part out, but we're just going to do it algebraically. Did your solutions match up to your roots from part A? Well, there's 2 ways in the math notes that it talks about solving. One is by factoring, and the other one is by the quadratic formula. Let's go ahead and look at factoring. Can we factor 2x squared minus 5x minus 3? And so remember, we're trying to set up the generic rectangle to match up with that. We know this has to be 2x squared, and we know this has to be a minus 3. We use the diamond problem to ask ourselves what multiplies to give us -6x squared, but adds to give us -5x. And once again, that goes back to kind of the algebra 1. And what you come up with is you have -6x plus 1x. So those are the 2 other pieces of the generic rectangle that you can put in. And then now you can work your way and figure out what needs to multiply to give us 2x squared, which would be 2x and x. And this will give us a minus 3, -3 times 2x is -6x. And then x times 1 gives us 1x, and then we can double check -3 times 1 is -3. So that allows us to factor 2x plus 1 times x minus 3. So it is factorable. And now you can use the zero product property to set our factors equal to 0. And the zero product property states that if 2 things or 2 numbers are being multiplied to give you 0, then either A has to equal 0 or B has to equal 0. And so since this is a product, length times width, we can do the same thing. So if we subtract 1, divide by 2, that's negative 1/2. And then on this one, we just add 3 to the other side. So we do see that when y is 0, x is negative 1/2. And when y is 0, x is 3, which does check back up to our graph that we did on part A. And that is to solve by factoring. We also have the option to solve this by using the quadratic formula when a is 2, b is negative 5, and c is negative 3. I'll scoot this over so you can see this possibility as well, where x is equal to the opposite of negative 5 plus or minus the square root of b squared, so that's negative 5 squared, minus 4 times a times c, and then all of that is divided by 2 times a. And then you have to simplify this to get your two answers. So underneath the square would be 25 plus negative 4 times 2 times negative 3 would be plus 24 over 4, which simplifies to 5 plus or minus the square root of 49. 49 is a perfect square, so 5 plus or minus 7 over 4, and then we have two possibilities, either 5 minus 7 over 4 or 5 plus 7 over 4, and those are your two. So that's negative 2/4, which reduces to negative 1/2, and 12/4 reduces to 3. And so now you have, once again, both your solutions, negative 1/2 and 3. So once again, it will work using factoring or quadratic formula. It's good practice for both of them. Question 60, examine the graph below with slope triangles A, B, and C. Part A, find the slope of the line using slope triangle A, slope triangle B, and then slope triangle C. So let's go ahead and start with slope triangle A. We'll notice that the change of x is 2 and the change of y is 1. So slope triangle A would be 1/2. Slope triangle B, now we're going over 1, 2, 3, 4, 5, 6, and up 1, 2, 3. So that would be 3 over 6, but still reduces to 1/2. And then on C, we have 1, 2, 3, 4, 5, 6, 7, 8 as your change of y, and then 4 as your change of x. So that would be 4 over 8, which once again simplifies to 1/2. So your slope, no matter which slope triangle you use, will always reduce to 1/2. Hernicia's slope triangle has a slope of 1/2. What do you know about her line? If the slope is 1/2, which is the same as the slope of this line, then the line would either have to be parallel to that line, or it would coincide, which means it would lay on top of that line. So once again, it's either going to be parallel or it's going to coincide with the line shown on the graph because they have the same slopes. Question 61. Francis and John are racing. Francis is 2 meters in front of the starting line at time t equals 0, and he runs at a constant rate of 1 meter per second. John is 5 meters in front of the starting line, and he runs at a constant rate of 0.75 meters per second. After how long will Francis catch up to John? What is it that we don't know? We know how far they're ahead in the starting line. We know what their rate of speed is. But we don't know the time as how far or how long they are running. So t is equal to the time, and the time is measured in seconds. We also don't know the distance, the total distance run. So we'll just use d is equal to the total, well maybe I don't even say total, but the distance whenever that might occur. And I think they're running, right? So the distance run or ran, and that would be in meters. So for Francis, he has a 2 meter head start and is running at a constant rate of 1 meter per second. So for Francis, his distance will equal 1 meter per second, so 1 times t plus the 2 meter head start. Whereas John has a 5-meter head start and is only traveling at a little less than 1, so 0.75 meters per second. So that's times the time plus the 5-meter head start. So how long will Francis catch up to John? Remember, Francis is 2 meters in front of the starting line. John is 5. So we can use the equal value method, and we can set these two equal to each other and solve for t. And then that will give us the time that they will be at the same distance. So we'll subtract 0.75t, and that'll be 0.25t plus 2 equals 5. Subtract 2, and that would be 3. And then divide by 0.25, and that would represent 12. So 12 seconds is when Francis will catch up to John. So after that, Francis will then be ahead. So make sure we answer the question that is being asked. Question 62. Solve each equation to find the value of x. Leave your answers in decimal form accurate to the thousandths place. So what is the thousandths place? Remember, tenths, hundred, thousand. So that'd be the third place here. All right, let's go ahead and solve part A. We have 3.2 over x is equal to 7.5 over x squared. So we can multiply both sides by x squared. So I'm going to go down here and kind of show you how that looks. That'd be 3.2 over x times x squared over 1 is equal to 7.5 over x squared, and then once again times that by x squared. So on the right side, the x squareds are just going to cancel and leave you with 7.5. On the left side, though, you have x squared over x. So one of the x's will cancel, but you'll still be left with an x. So 3.2x equals 7.5. Divide both sides by 3.2, and x is equal to, I should say it's approximately, because we are going to round, so it's approximately equal to 2.34375, but we want to round that to the nearest thousand, so that's this place right here. And since this is a 7, that number is going to move up. So x is approximately equal to 2.344. And that's for part A. For part B, looks like we're going to have to do some distributive property. So this will be 4x minus 8 plus, or I guess I could do, since it's going to be negative 3x, I'm just going to do minus 3x. And then looks like plus 12 is equal to, and then distribute the negative 2, negative 2x plus 6. Combine your like terms, that'll be x plus 4. And then we can add 2x to both sides. So 2x plus 1x is 3x. Subtract the 4. 3x is equal to 2. And divide by 3. And since it does want us to round, that would be 0.667. It is 2/3, which is 0.6 repeating, but because it does ask us to round, we want to make sure that we're following the directions. Part C, looks like we have a quadratic, so we have a choice here. Do we want to solve using the quadratic formula? Do we want to potentially try to factor it? Completely up to you on how you want to do it. I'm going to go ahead and use the quadratic formula. A is equal to 2, B is equal to 7, and C is equal to negative 15. So x is equal to the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, 2 times 2. So if we simplify that, that would be negative 7 plus or minus the square root of 49. And then 2 negative signs will be a positive here. So that's going to be, it's like 120 over 4. And that'll be negative 7 plus or minus 169, which is a perfect square. So now we have negative 7 plus or minus 13 over 4. And then that's two different possibilities. So we get negative 7 minus 13 over 4 and negative 7 plus 13 over 4. So that's negative 20 over 4, which gives us negative 5. And then this would be 6 over 4, and that would be 1.5. So we get two solutions. X equals negative 5 and x equals 1.5. And then on to D. Move this up a little bit here. So on part D, it looks like we have another quadratic, 3x squared minus 2x equals negative 1. We do want to set this equal to 0, so we're going to add 1 to both sides. 3x squared minus 2x plus 1 equals 0. So now let's go ahead and do the same thing. We'll do the quadratic formula. X is equal to the opposite of negative 2 plus or minus the square root of b squared, so that's negative 2 squared, minus 4ac all over 2 times 3. That simplifies to 2 plus or minus the square root of 4 minus 12 over 6. And that's 2 plus or minus the square root of negative 8 over 6. And hopefully this right here sticks out a little bit. You can't take the square root of negative 8 because there's no real number that when you multiply by itself you get negative 8. So therefore on D there are no values of x, no real values of x that make this true, so there are no real solutions. Question 63. Find the perimeter of the shape below. Clearly show all your steps. So to find the perimeter, we need to find the other side lengths. We do have a right angle and 17 degrees, so we can use our tangent ratio. We know that tangent of 17 degrees is equal to delta y, in this case, which would be 9 over, I'm just going to make this x here, x. So we can solve for the x value, figure out what tangent of 17 degrees is. Make sure your calculator is in degrees. And this is approximately 0.3057. And that's approximately equal to 9 over x. And then we can cross multiply. We get x times 0. Well, let me fix that. We'll do 0.3057 times x is equal to 9, and then divide both sides by 0.3057. Oops. And so x is approximately equal to, so x is approximately 29.44. If you use the approximation, if you use tangent 17 all the way through, it'll be 29.437, which I guess would still round to 44 anyways. So that would be x. Now to find the other side, now we'll probably have to go ahead and use Pythagorean theorem. So this will be 9 squared plus 29.44 squared is equal to, let's call it c, is equal to c squared. 81, and then 29.44 squared is approximately 866.71. Add that to 81 is 947.71, and then we can take the square root of both sides. So when we take the square root of that, we get C is approximately 30.78. Now I've done some rounding, so we might get some different answers depending on how far you round it out on each of these as well. But it should be approximately 30.78 centimeters. So therefore the perimeter, you have your 9 centimeters plus the 29.44 centimeters plus the hypotenuse 30.78 centimeters, and that will give us a perimeter of 69.22 centimeters. And once again, that's an approximation because we've approximated the tangent ratio, we've approximated the hypotenuse using Pythagorean theorem. But that's a close approximation of what the perimeter should be of the shape.